Hopefully everybody took your Renaissance test yesterday. If not, excuse me. If not, you need to go take it today. It's an easy 100. If you do it, you get 100 for a test grade. If you don't do it, it's a 0 for a test grade. So just go do that Renaissance test. It was yesterday 4/19, I think. And then the day before, we had a little test I said 4, it's 5/19, May 19th. And then the day before, May 18th, we had another little 10-question test over complementary, supplementary, angles, and fractions. So make sure you've taken both those tests. Those are the last 2 tests for the 6 weeks. So now we're just going to finish off this 6 weeks with just some more reviewing basic algebra skills that we've learned, but without a graphing calculator, and also practicing with our geometry. So today we're going to go back over polynomials. And of course, polynomials are terms that are separated by plus and minuses. So in this first parentheses in this number 4, there are 1, 2, 3 terms. This is a trinomial. Tri meaning 3. This parentheses has 1, 2 terms separated by the minus sign, so this is a binomial, right? If it's a single term, like if this was just 5x, that would be a monomial. So monomial is a single term, binomial is 2 terms, and trinomial is 3 terms. And they're called polynomials if they're all called polynomials, and then 4 and more are all considered polynomials too, just many terms. Okay, so there's a little vocab history. We added polynomials, we subtracted polynomials, and we multiplied polynomials. So anyway, that's kind of what we're going to practice today, is adding, subtracting, and multiplying. Tomorrow we're going to go backwards and factor, taking the answer to a multiplication problem and finding the 2 things that multiplied to get you there. So anyway, addition today. Remember, if you're adding it, so this is not a multiplication problem because there's a positive sign or plus sign between this, so this is an addition problem. So if we are adding, that is adding like terms, combining like terms, which means I just need to get rid of parentheses and combine. X's go with X's, numbers go with numbers, X squareds go with X squareds. So think about parentheses. How do we get rid of parentheses? When you can't do what's inside, because we always check first inside, and if you can't do what's inside, I need to multiply what's right in front of the parentheses to get rid of the parentheses. And of course, multiplying by a positive 1 does not change anything. So this is still 5x plus 9. And then I have another set of parentheses. Again, I can't do what's inside because x and 8 are not like terms. Cannot add them together. So what number's right in front of the parentheses? Another positive 1 because it's a plus sign. And when you multiply by a positive 1, nothing changes. This is still a positive x. And this is still a minus 8. So now the parentheses are gone. Now you can combine your like terms. X's go with x's. Numbers go with numbers. So this final thing here, if I add 5x plus 1x, excuse me, guys, I get 6x. Allergies are bad right now. 9 minus 8 is a positive 1. 8 bad guys killed 1 of my good guys, and I'm left, 8 bad guys killed 8 of my good guys, and I'm left with a positive 1 good guy. All right, so 6x plus 1 is your final answer because x's and numbers cannot go together. They're not like terms, so you got to know when to stop. This is another addition problem, so you can do the same thing. So if you got this, pause the video, go do it. I'm also going to do actually, I'm just going to come down here for a sec. So we're going to multiply by positive 1 to get rid of the parentheses, and you can just kind of do that in your head if you want to, because multiplying by positive 1 changes nothing. So just pretend the parentheses are gone. Same thing here. If you're multiplying by positive 1, nothing changes. X squareds go together. So here's 2x squareds and 1x squared. 2 somethings plus 1 something is 3 somethings. Do not change the somethings. Do not make it x to the 4th. Don't change my somethings when you're adding and subtracting. And then x's go with x's, but there's no x's over here, so just plus 6x. And then my plain numbers go with my plain numbers. -1 plus -4, bad guys and more bad guys gives me a bunch of bad guys. And none of these are the same. They're not like terms, so that's as far as you go. X squares and x's cannot be combined together. They are not like terms. Okay, so those are the 2 addition problems. Let's look at the subtraction down here. So same concept. I am adding or subtracting. I'm just combining like terms, but I got to get rid of the parentheses. Can you do what's inside this parentheses? No, they're not like terms, so how do we get rid of parentheses? You distribute what's right in front of it. And what's right in front is a positive 1, which means nothing is going to change. This is still 11x plus 3. But here's a second parentheses. Again, you can't do what's inside the parentheses, so we want to distribute what's right in front of it. This one is no longer a positive 1 like it was up here for addition. It is a negative 1. And multiplying by a negative 1 changes the sign. Instead of being a positive 4x, this is now a negative 4x. Instead of being a positive 1 or negative 1, it's now a positive 1. So multiplying by a negative number changes the sign of everything that you multiply. Multiplying by a negative 1 changes the sign. So this subtraction is gone. and those pieces are gone. Don't use them, cross them off so you don't get tempted to do it. Now these did not change, so 11x goes with my negative 4x, and 11 minus 4 is 7x. Good guys, 1, right? And then I have a positive 3 and a positive 1, and of course that is plus 4. And 7x and 4 cannot go together because they are not like terms, so that is your final answer. All right, so there's another subtraction one to do down here, and then let's go do a multiplication one. So again, multiplication because there's nothing between the parentheses. Now you can always check first to see if you can do what's inside. I always check that just in case because it makes the math easier if you can do anything inside. But these are not like terms, and these are not like terms. This is not a monomial, this is a binomial, and this is a binomial. So this is a double distribution. The x has to be distributed to both pieces over here, all right? And then you're going to come back and distribute the 12 to both pieces over here. So remember, this is multiplication. X times x, add the exponents, that's x squared. X times 2 is a positive 2x. It's positive times positive is a positive answer. Then positive 12 times x is a positive 12x. And a positive 12 times a positive 2 is a positive 24. Now, parentheses are gone, combine like terms. Now we're back to adding and subtracting. Like terms, 2x and 12x go together, and positive 2 and positive 12 is positive 14. So the answer appears x squared plus 14x plus 24. Now this is the answer to this multiplication problem. This parentheses and this parentheses are factors. Factors are the two things that multiply together to give you this answer. Tomorrow we're going to take this answer and go backwards to figure out what two things got multiplied together to give you this answer. So when we go backwards to finding the things that multiply together, that's factoring. Factors are the things that multiply together. So tomorrow we're going to do this in reverse. Take the answer and go back and find the two things that multiply together. All right, another multiplication one. This is a binomial times a trinomial. So first one times the first one times the second one. The x is going to be distributed to all three pieces. Then we come back and do the negative 3 times the first one, negative 3 times the second one, negative 3 times the third one. So more pieces to distribute than up here because there was a trinomial in the second part. So let's just go do it step by step. X times x squared. Again, you add your exponents. So this is a 1 plus 2, so this is x to the third. And then I'm going to do x times negative 7. So negative 7 times 1 is still negative 7, but x times x is x squared. And then I do the x times negative 2. So I have negative 2x. So the x has been distributed to all three pieces. Now I'm going to do the negative 3. Negative 3 times x squared is a negative 3x squared. Negative 3 times negative 7 is a positive 21. There were no x's in this piece, but there is an x in this piece, so I still need to keep that x in the answer. Be careful that you don't forget to write the x's down. And then negative 3 times a negative 2, negative times negative is a positive answer, and that is 6. And then combine like terms. I got an x cubed and no other x cubed, so I'm going to write the final answer up here. X cubed has nothing else to go change it. X squareds go with x squared, so negative 7 and negative 3 is a negative 10. Bad guys and bad guys, x squareds. And then I have a negative 2 and a positive 21x. So 2 of these bad guys killed 2 of my good guys, so I'm left with 19 good guys, plus 19x. And then I still have, I think I've used everything except the plus 6, so I still have a plus 6 on the end. And none of these are like terms, so that is your final answer on that. Wasn't that fun? Okay, so you have another double distribution to do down here. You've got down here, remember, follow PEMDAS, try the parentheses first, but you can't do what's inside, so distribute to get rid of parentheses, right? And then once parentheses are gone, combine like terms. 23 is an interesting one, so I'll do that one in just a second. But let's go ahead and pause the video, go do any that you haven't done, come back and check your answers, and we'll look at these. Okay, so hopefully you pause your video, you're coming back and looking number 11. If you did number 11, hopefully you got 2x squared plus 10x minus 1. If you did not, you might want to double check and see if you got this, because multiplying by positive 1 did not change anything, but multiplying by negative 1, this became negative, that became positive, that became negative. So maybe you forgot to write down the new signs when you did this. And then combine your like terms. X squareds go with x squareds, x's go with x's, and numbers go with numbers. The other one we did not do was number 19. So it was a double distribution. So here's number 19. So if you did your double distribution, I didn't show all the steps, but this was the 5x times x squared, so I'm just wrote them down here. The final answer was 5x cubed plus 3x squared minus 20x minus 12. Because they had some, it wasn't the typical x times x, it was x times an x squared, and so forth. So anyway, this was a really interesting one. The pieces were all the same here. None of the pieces changed because none of these are like terms. I just rearranged them in descending order with the third power, then the second power, then the first power, and the number on the end, because most mathematicians will write them in descending order like that. But the original answer was right too, because there were no like terms in that. All right, let's do number 20. Oh, we haven't done, let's see, number 21. 21 down here. Where's 21? There it is. So you distributed 5 times 2x and got 10x. You did 5 times negative 7, got negative 35. Negative 2 times 5 is a negative 10x, and negative 2 times 7 is a negative 14. Were there any like terms? Yes, x's went together and the numbers went together. So you should have gotten, oh, negative 49, because did the x's cancel out? Yes, positive 10 and negative 10. So the x's totally went away and you just combined your numbers and got negative 49. Okay, let's go look at 23. I'm going to see if I can rewrite this one up first. We have a little bit more room to do this. Now this parentheses being raised to the third power. Now you can't just say 3 times the exponent and 3 times the exponent, because that rule only works when this is a monomial, and this is not a monomial. So the easier way to do this one is to literally say this parentheses is being multiplied times itself 3 times. That's what the exponent is saying. So x plus 4 times x plus 4 times x plus 4. All right, so that's what this means to the third power. I'm multiplying the base times itself 3 times. So this is a multiplication problem. So just like if you had 2 times 3 times 8, or let's make it times 3. Let's do 2 times 3 times 3. You would do 2 times 3 first and get a 6, and then 6 times 3 is 18, right? So we're going to multiply the 2 together first and get an answer, and then multiply it times the last one. So I'm going to take these first two, binomial times a binomial, and multiply them together first, get an answer, and then multiply it times this one. So double distribution, x times x, x squared, x times 4 is a plus 4x, 4 times x is plus 4x, and 4 times 4 is plus 16. Okay, so there's this first piece. I'm going to go ahead and keep it in parentheses so I can see it, because I'm just going to take this answer and multiply it times x plus 4. Now, before I do that, though, I'm going to go ahead and simplify this, because are these like terms? Yes, so this will give me a little bit easier problem if I do this. X squared plus 8x, so this is now x squared plus 8x plus 16. Oops, 16 didn't look very pretty there, 16. And I multiply that times x plus 4. Okay, so this trinomial is the answer to the first two being multiplied together. I still have to multiply it times the second one. So every piece over here has to multiply this. So it's x squared times the first one, x squared times the second one. 8x times the first one, 8x times the second one. 16 times the first one, 16 times the second one. So this is, you're doing a lot of distribution. You just repeated distribution. So x squared times x is going to give me x to the third. Let's see if I can write this without it moving the paper. There we go, x to the third. And then x squared times 4 is just 4x squared. So plus 4x squared. Now I'm going to distribute the 8x. 8x times 8x is 8x squareds. So plus 8x squareds. And then 8x times 4. 8 times 4 is 32, and I still have an x with it. And then we're going to come back and distribute the 16. 16 times x is a positive 16x. And then 16 times 4 is 64, so plus 64. We will plus 64 down here. Here we go. So all the distribution's been done. Now all I need to do is combine like terms. There's only one x cubed, I think. Yep, so x cubed stays x cubed. I can write, keep the paper still. X squareds go together. These two, there's only two. Yes, so 4 plus 8 is 12x squareds. 12x squareds. And then I got 32x and 16x, and 32 plus 16 is 48x's, plus 48x. And then I still have this plus 64 on the end because there's no other plain numbers. So I got a cubed, x, or to the third power, I got a squared, a second power, I got a first power, and a 64. None of those are like terms, so that is your final answer on that one. Wasn't that fun? Okay, so once you get the distribution part, it's just over and over and over, no matter however many pieces you have. It's just distributing everything on multiplication. Now, the other side, what we're going to do is similar figures, okay? Similar means that they have the same shape, but one's been blown up bigger or shrunk down compared to the other one. All right, so, and you have to, sometimes they're going to give you some problems and say which one is similar to the one that they're talking about. Now, rectangle ABCD is this one. So this one has ABCD. Okay, so this is the rectangle that we're wanting to find one that's similar to. So if they're similar, The sides will be in the same proportion. See how this one looks really skinny and long compared to this one? So they should have the same shape. And one way that you can do that mathematically rather than just trying to eyeball them, because sometimes they'll look very similar and you're not really sure which one is the truly similar one. This ratio will be the same. In other words, the fraction. If I make 4/6 out of this, 4/6. If I just make a fraction out of that, short side over the long side. If you put that in the calculator and reduce this down, it winds up being 0.66 and it keeps going 0.6666, so repeating. 6 is repeat. So if I take the short side and put it over the long side, 2/8, and put it in the calculator and see what it's equal to, this is equal to 0.25. It reduces down to 1/4. This one reduces down to 2/3, by the way, but we can just do it in decimal form because that's easy on the calculator. So is this one have the same ratio? No, it does not have the same ratio. It's not 0.66. If you put 6/9 in the calculator and see what it equals, and you put short side over the long side, 2/4, and of course this one is 0.5 because that's 1/2, so that's not it. But if you put this one in the calculator, it also tells you 0.66. So which one has the same relationship? These have the same shape. So bingo, that one has your shape. So one way to do it is to literally just make a little ratio out of the sides. All right, here's another one. Find the value of x in each pair of similar figures. What they love to do with these is if these two are similar, right, they're going to have you find the x. Let me find where x is. Oh, x is this length over here. So big X is the points. This is triangle x, y, z, and this is triangle u, v, w. So they tell me this one's 20, and see how these two short sides are corresponding? They go together, right? They're corresponding sides. This long one on the bottom corresponds to this long one on the bottom of this one. This slanted looking one corresponds to the slanted looking one over here. Okay, so they're all proportional. So if you notice that this one is a 4 and this is a 20, if I multiply 4 times some number, what will equal 20? Well, if I multiply it by 5, that's what I get over here, right? So this thing is 5 times bigger than this one. So that's my scale factor. So if I multiply 4 times 5, I get 20. If I want to know what this one is, I can just take this number and multiply it also by 5. It will have the same scale factor. And 7 times 5 is what number? 35. So x is 35. So one way to do it is to look to see if there's a really simple scale factor, like multiplying by 2 or 3 or 4 or 5, something like that. They're really easy to do that way. Sometimes it's not a nice, pretty whole number, in which case there's another technique we can use. But if it's just a really simple one like that, you can just look to see, hey, what did they multiply by to get to the big one? All right? So that's the easy way to do those. We can also set up a proportion, which is the butterfly, and we'll talk about that. You could have done short side to long side, short side to long side. So you could have done 20/x is equal to 4/7. And then you could have done it by multiplying these two together and doing those two together. And you could have said 4 times x is equal to 7 times 20, which is 140. And then you would divide by 4 and divide by 4 to find out what x is, right? And 140 divided by 4 was 35. So you could have also set up this way. So when it's not just an easy multiply by some number to get there, you can set up this proportion and do it that way. All right, here's 2 more similar figures. This side is 13. It corresponds to this one. See this kind of a longer side over here? It kind of corresponds to this one, and then these correspond to that one, and this one corresponds to this one. And we are looking for x, and x is this one. So the 2 that correspond is this one and this one. So that's where I can figure out what the scale factor is. Is there some number times 13 that will equal 39? If you're not sure, take 39 and divide it by 13 and see what they multiply by. If you do 39 divided by 13, you find out that it equals 3. So now check it. 13 times 3, do you get 39? Yes. So this is times 3 will give me this number. So I'm looking for this side. Is this the corresponding one? And I know what it is. So if I take 15 times 3, it should equal this side. And 15 times 3 is 45. So my missing side is 45. And again, you could have set this up with a proportion. You could have said 15/13. This side over that side is the same as this side over that side. I'm doing the same order. This one over that one, this one over that one. So x over 39. And then you could have done your butterfly to solve for x. Okay, so that's another way to do it when you just can't pick out the easy number like that. All right, they love to do these problems, especially on the STAR test, and well, I mean not necessarily the STAR test, but on the college entrance exam test. A flagpole casts a shadow that's 20 feet long. So on the ground, the shadow of the flagpole is 20 feet long on the ground. At the same time, Humberto, who is 6 feet tall, cast a 5-foot shadow. So his shadow on the ground is 5 feet. What is the height of the flagpole? Assume the triangles are similar. So that's what they did. It was how they would measure things when they didn't have something to go measure up high in the air. They could do this. So if this is my flagpole and the sun is shining up here in the sky, right? Here's my sun with rays coming off of it. Pretend that's a little sun up there. It's not a very pretty sun. Let me try a little bit better. There we go. So my sun is up here in the sky and it's casting a shadow on the ground. And this is the length of the shadow on the ground. So at the exact same time of day, I have the 6-foot person standing next to the flagpole, and he has a little shadow. So see how this triangle that's formed, if I connect the top of the flagpole to the bottom of the shadow, if I connect the top of the person to the end of his shadow out here, these two triangles are similar, right? So I can do the same thing. If I want to know the height of this flagpole that I can't measure because I don't have a big tall ladder, what I can do is say this is to this as that is to that. It's a proportion. Now, to get from the small one to the big one, can I just multiply by a number? Yes, this is times 4. 4 times 5 gives me 20. So what's 4 times 6? Yes, so this would be a 24-foot tall flagpole, right? Everything's in feet. Always make sure that all the units are in matching units. Otherwise, you'd have to convert to all the same units. Now, you could have also made a proportion out of this. You could have said 6 over 5 is equal to x over 20. Or you could have said 5 over 6 is equal to 20 over x, as long as you're consistent with the way you set those up, right? Okay, and then do that proportion little butterfly thing if you wanted to. Which triangle below is similar? So if you want to, go ahead and give these a whirl and come back and we'll check them here in just a sec. So go give these a whirl, pause your video, come on back when you're done. Hopefully you're coming back. Which triangle below is similar to triangle FGH? So we need to find FGH. And here's FGH. So here's FGH. So FGH is in this order, and all of these kind of have the same sort of shape to them. So here's the short side and here's the long side. So if I make a ratio out of this, 2 over 5, and put it in the calculator and see what that's equal to. 2 over 5 in the calculator is the same thing as 0.4. So all I got to do is put the short side over the long side, short side over the long side, short side over the long side, and see if any of these equal 0.4. Obviously, if this is a 2 and that's a 2, it shouldn't be a different number. It should be a 5, right? Because they would be identical, so it can't be that one. But if you put it in the calculator, it's 1/2, which is not what we wanted. 4 over 10, if you put 4 over 10 in the calculator, guess what? It does equal 0.4, so that's your winner. Now, there could be one more. If you put 1 over 4 in the calculator, it's 0.25. So if you pick this one, you were right. Triangle CBA was the same as FH. I'm looking to see what order they did. They did FGH. So if they go in this order, FGH, you would call this one CAB. You would do the same order of points as they did over here. So this is the same as this. Anyway, we'll talk more about that tomorrow. Which parallelogram is similar to the parallelogram HJKM? HJKM is this one. Oh, is that right? Yeah, just to have that right, HJKM. So this is 12 over 15. I'm going to take the slanted one over this bottom one, just to have, it doesn't matter. You could put 15 over 12 if you wanted to. I'm just going to do this side over the 15. So put that in the calculator and see what it equals. Hopefully you did it and it's 0.8. And then I put the same order, this one over that one, this one over that one, this one over that one. Put them all in the calculator and see which one gives you the same as 0.8. That will be the similar one. They will have the same ratio. All right, that makes the same shape if they have the same ratio. And a ratio is just a fraction, by the way. Okay, so which one worked? Hopefully you did that. And yes, it was this one here. That was the one that worked. Find the value of x in each of the pair of similar figures. So we've got two sets. We got a set of similar triangles, and we have a set of similar rectangles. So let's see, I have this side and this side and this one, and I have an x in this side and this one, which is good because this side goes with the base that I don't know. But this side, I have a corresponding unit over here, and I have this side over here. So you could look to see, is there an easy way to get from the small one to the big one? 6 times some number gives me 30. Is there a number that does that? Yes, this is an easy one. It's times 5. So the scale factor is 5 times bigger. So 6 times 5 is 30, which means 5 times 5 is 25. Could you have set it up with a proportion or a butterfly problem? Sure, you could have said 5 over 6 is equal to x over 30 and then done the butterfly. You could have also done 5 over x is equal to 6 over 30. As long as you're consistent with how you set it up, it will work. So there's several ways to set them up as long as you're consistent with putting the same pair each time. Meaning I can't put this over that and this paired up over that. So this is to this as that is to that. Or this is to this as that is to that. So a couple of ways to do it. All right, this one, let's see if it's an easy one. Here's my missing side. And, oh, look, here's the side over here. Now, since this is a rectangle, if this is 14, is this one also 14? Yes, which is nice because I'm looking for this side over here. It's the same. 14 and this correspond. And the vertical corresponds with this vertical, short to short, long to long. So to get from 14, the small one, to the big one, is there a number you can multiply by? If you're not sure, take 28 and divide by 14 and see what the number is. It is times 2. 14 times 2 is 28. So that's my scale factor. So, oh, I'm going the other way, aren't I? I need to go this way. So 28 divided by 2 equals 14, right? So to get from 14 to this side, I need to also divide by 2. So 14 divided by 2 is 7. Because when I multiply, 7 times 2 is 14. 14 times 2 is 28. So the scale factor is 2. Multiplying to get to the bigger one, dividing by it to get to the small one. All right, there is it for today for similar figures. Hopefully all that made sense, and we'll practice some more similar figures tomorrow.